All right, well, welcome everyone to the Happy Boolo LEED and Zero Energy Renovation Home Tour. Before we get started, a real quick to our top tier sponsors, Platinum Level Mitsubishi Heating and Cooling, Heating and Air Conditioning rather. In the dead of winter, I've had this system now for going on almost 4 years. And it pulls heat right out of the air using hyperheat technology, keeping my house nice and warm and of course cool in the summer, just like an air conditioning system working right in reverse. It's a full ducted air source heat pump system as well. And if you're too nervous or your clients are have concerns about going all electric due to the grid or electric costs, that's okay. You can do the outdoor condenser just like I showed you, and you can still keep the indoor as a methane or propane gas furnace. This uses Mitsubishi's IntelliHeat technology, and it can work with pretty much any furnace with the indoor box going on top of that, the outdoor condenser, and might be available for Inflation Reduction Act tax credits, especially if the indoor furnace is over 80% efficient. And speaking of those tax credits, Mitsubishi makes it very easy to try to match indoor with outdoor systems for the North and the South, trying to understand which systems may be approvable for those tax credits. These systems also work as mini split technology, which is the most energy efficient and reduces the air leakage and other issues that ducts cause. And then there's also mini splits that can be hidden if you don't like to look at those behind the walls. And they can be ducted mini splits, which are the best of both worlds. Make sure you hire a diamond contractor to help assist you with your project. You can check them out on their website to find one in your local area, and that you can learn more about all of their products and contractors over at MitsubishiComfort.com. We also want to thank our second tier gold level sponsor, Serve Build Equinox. They're making smart demand controlled ventilation with built-in conditioning to heat and cool as well. Built in solar-powered manufacturing facilities in the Midwest and using smart ventilation technology, which we'll talk about in this session. All right, again, welcome everyone to the Happy Boolo LEED and Zero Energy Renovation Home Tour. Before we get started, I just want to let you know that this session is brought to you by the Green Home Institute. Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the place we live. We are a small but mighty team, and I will be your moderator today. My name is Brett Little, and I am the education manager here. As always, these sessions are approved for multiple continuing education units, including all 5 pillars of green in our Certified Green Home Professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Make sure to look for that passive house code at the end if you're trying to get your passive house CEUs. Well, I am very excited to welcome Amy and Mike back to our webinar series. They first presented last during our 2021 Residential Net Zero Energy Conference panel. So they're back to give us an update on their project and where they're at. Since then, they have managed to achieve LEED Platinum certification with the highest score that I've ever seen for V4.1, 95 points. They got the EPA Indoor Air Plus certification, a negative HERS index rating of -9, and the Green Home Institute Zero Energy Certification certificate. This project involved not 1, but 3 different GHI members on design, HVAC design, and rating, who all came together to make it happen. Now, in this course, we will be focused on highlighting some of the benefits of LEED residential certification program, including energy and atmosphere, annual energy use, water efficiency, total water use, sustainable sites, rainwater management, and environmental quality ventilation. Amy, Mike, welcome. Please tell us a little bit more about you and your home before you go ahead and take us on this virtual tour.
Hi, everyone. I'm Amy Myers.
And I'm Mike Baker.
And we are very pleased as homeowners to share elements of our Happy Boolo project with all of you. When you consider a project essentially transforming our 1964 split level into a LEED Platinum home, the only LEED Platinum 4.1 renovation in the Chicagoland suburbs, it's really easy to wonder, why did you do this? Because as you might imagine, that's no easy feat. We had actually just been looking very pragmatically for a home with just a bit more space, as at least I was going to be running my business consulting practice from our home, and we just needed a bit more space. But the real reason we stayed in this home that we had purchased in 2000 was due to our Drury Lane community in Arlington Heights, Illinois. They kept us on our street. Essentially, we are living in a community where everyone does know everyone else's name, socializes with each other regularly, and we really look out for each other. And many strong friendships have developed up and down the block over the years. And there are many neighbors who have actually made the same decision over the years as us to stay because of the tight-knit community. So once we committed to stay, we challenged ourselves to make every part of our 1964 home as functional as possible, supporting the key activities in our lives that are most important to us, which some of those are growing food behind the house in our garden, making food, sharing food with friends, family, neighbors, and our broader community. So throughout the project, we asked ourselves, how functional, for example, is a guest room where people stay maybe 5 to 6 times a year maximum? It seems like wasted space. So what can we do in this home as we renovate to make every single inch of space have maximum functional value for our lives as well? And then finally, and the reason probably most of you are all here, is we were inspired to take on the even bigger challenge of expanding our commitment to sustainability, a commitment we had been applying to how we garden using, for example, no chemical inputs in our garden, to the full footprint of our house, and considering dimensions such as energy efficiency, water use, air quality, food production. So we were up for the challenge. And this became our philosophy: community, functionality, and sustainability, which you're going to hear my husband, Mike, talk about in the video. And this philosophy really did guide us in a lot of our decisions throughout the project. We kept that front and center. So we hope what we did in our project can be helpful to the broader community of people like you who are interested in having more and more homes go as green as possible. Both the high points of our project, which there were many, and the mistake and lessons learned, is there are definitely aspects of our project that we would probably do differently if we could rewind time. So we really thank you in advance for your interest, and we are excited to take and field all the questions at the end. So thanks, guys.
This is the Happy Boolo project, 631 North Drury Lane. It took us 3 years to get here. We basically converted our house, a 1964 split, to become the first LEED Platinum remodeled house on the LEED 4.1 program in the Chicagoland. Our philosophy my wife and I developed was 3 parts. It's community, we wanted to stay in Arlington Heights; functionality, we wanted to have a house that worked for us. We knew that one of us at least would be working from home, and we needed a home that allows us to really express our culinary desires. What you're looking at here is the site of the design charrette that we had. This was the dining room table, used to sit here. So around this table, we had all the key stakeholders for the project. And that earned us a single credit. And we felt that was absolutely vital to having a really good project. You needed to have all the key contractors and subcontractors that are on the project present in the room at the same time, so everyone knows what they're doing. So I used to think that for a home to become energy efficient, you only needed to do 3 things. You needed to have a tight thermal envelope, you needed to have solar PV system, and you needed to have electric heat pump technology. Now what I realize is, in addition to those 3, you need to have mechanical ventilation because it's an airtight home, and most importantly, as we discovered, you need to have supplemental dehumidification. And what we're going to do is take you through all 5 of those. So as far as the thermal envelope is concerned, what I learned is that the new part of the house that we did, well, not the new part, but the existing part of the house, the thermal envelope is different depending on where the house, what part of the house you're looking at. So here in the kitchen, what we have on the outside of the house, you have a masonry wall. We had brick on the outside. And behind that brick, you had plywood. This is from 1964. And then behind the plywood, you've got the stud wall. And in that, we had typical fiberglass insulation from 1964, or whatever the material would have been. Above that concrete sill outside, we had wood siding. And behind the wood siding, we had plywood, and then behind the plywood we had the stud wall again and more of that 1964 insulation. So that was all replaced on this floor with a new anatomy, we'll call it. On the outside we have hardy board siding. Right behind the hardy board siding we have a moisture barrier, which is what's called the Tyvek moisture barrier. Behind that we have about 1 inch of rigid foam insulation. And then behind the rigid foam insulation, that's where we have our plywood, or our OSB, the strand board. And then behind that we have the stud wall. So we're actually insulating the outside of the home directly behind the siding. Basically what this does, this is what's called a mini split. Split meaning it provides heating and cooling. So these are all 9,000 BTU units that we have in the house. They're all being serviced by a large multi-unit outside, which you'll see later. But these provide heating and cooling. What they do in the summertime is they also provide a bit of dehumidification. This is where we ran into some troubles with our HVAC design, where we needed supplemental dehumidification. The thermostat here actually controls, you know, each mini split in the room on different zones that we have. What dry mode does for these mini splits is it slows down the fan speed. That allows moisture and condensation to actually drip off of the coil that's inside of these and drips into a drain pan, and then that water drains away through the line set. What's interesting about here is that it's never cold in the wintertime in this room, because the walls up here, this is the new addition of the house. So we've got like R60 in here. It's like castle wall thick up here. So we're never really cold in here. This mini split will stay on, you know, all winter for us, and it just puts out a little bit of heat, and it just keeps us around, you know, 70, 68 degrees, something like that in the wintertime. My wife wants it a little bit warmer. I like it a little bit cooler. We compromise somewhere in between. But in the summertime, obviously heat rises, so it will get, you know, you would expect that it would get warmer up here. You know, your upstairs is usually warmer than your downstairs. That's still the case for us because heat naturally rises. But what we don't have is a lot of that thermal transfer from the outside in, and that is provided by the windows. The windows are also part of your thermal envelope. So what you want to do is have a window that has the ability to reflect a lot of the sunlight back out versus letting that sunlight pass through. The glazing on the outside of these windows reflect a lot of that heat back out. So that's how it keeps the room from heating up in the summertime. Conversely, in the wintertime, it's 2 panes of glass, and in between the glass is argon gas, which is an inert gas. And that gas does not allow thermal transfer to happen. So in the wintertime, the heat that's in the house doesn't pass through to the outside. So that's how you get the best of both worlds. These particular windows are fabulous because they're more the European crank style. So you can really control how tight and how sealed they are up against the house, which is great. So you can cinch them up and lock them into place, and that really locks the seal in. So it's really airtight. It's really nice. really can't hear anything outside. Our bedroom, I sleep on this side of the bed. This is Drury Lane right here. So the front of the house is right here, and there's trucks and stuff going by all the time, but I really can't hear it, which that's nice. So the windows do have a sound dampening effect, which is pretty nice. This is what powers the mini split. So this is basically a Mitsubishi heat pump system. This is what's called a multi-unit. So this is what's providing the heating and the cooling for us. And the line sets go into the house. They penetrate the house in there underneath the deck. So what's unique about this kind of system is that it is capable of dynamically adjusting its tonnage based upon what's being called for in the house by the mini splits. So this is a 48,000 BTU unit, and it's capable of lowering itself down to about 16,000 BTUs. I believe that's the case, but it is capable of adjusting itself, and that's where the some of the rating codes are a little bit behind, because they're not taking into account these things are able to do that. So technically it's oversized. It's a 4-ton unit. It's oversized, but often the energy models don't take into account that you can actually it can self-regulate itself, and that's not often taken into consideration. But in this case, it was. So that's good for us.
Now, Mike, before we move on and head down in discussing ventilation systems and the humidity control, and while we're talking about the heating and cooling, first, just reminding everybody, one of the components of the LEED energy and atmosphere minimum energy performance is, everything you're talking about, this tight envelope, the shell, the windows, the high performance HVAC systems. Those go all into achieving the Energy Star requirements, and they can be challenging, especially on existing homes, to meet, and then also going above and beyond with the energy credits. But Mike, you and I were talking before this, and can you just give us a little more input on some of the challenges you face with the heating and cooling side there?
So when we first moved back into the house, we moved back into the house in January, in winter, and great, it worked fine. We had no problem with heating whatsoever, and of course in the winter there's no problem with humidity. In fact, we all know in Chicago it's everyone gets really scratchy and itchy, and we don't have a humidifier that puts humidity in the air. We just we don't ventilate whenever we take a shower in the winter, for example, so that imparts some humidity into the room, so we didn't discover until Memorial Day weekend of 2021 that we had an issue with humidity. That was the first real blast of hot, humid weather that we had after we'd moved in. And I could not get the humidity down below 60% in the house. And I started chasing numbers and calling people to figure out what's going on. The instinct for someone who comes from a conventional home is crank up the AC. So turn down the temperature. And as I learned from all the different help that I eventually got, is I think I got this from Ben Newell, actually, as temperature goes down, the relative humidity goes up. So I was creating basically a New England shoreline effect inside the house. It was like a cold, clammy environment. So I couldn't figure this out. And that's when I figured out that these thermostats that we had, or the mini splits that we had purchased, did not have the dry mode enabled by default. So I had to go into the firmware and actually unlock the dry mode. And as it was explained to me by Mitsubishi, dry mode slows down the fan speed, because even on the lowest fan speed on the cool setting, that fan speed is still too high, that it blows that condensation right back out into the air again. So you're like a dog chasing its tail. So once dry mode was enabled, that at least slowed the fan speed down so we can get that down. However, it was still, we were barely able to keep it below 60%. And when you have an airtight home like this, it's difficult. Now, we have the ERV. So the CERV obviously is allowing us to ventilate that out. But as we learned, when the CERV ventilates, if you're already bringing in 96% humidity air outside, you're right back to where you started again. So both the CERV is not supposed to be a centralized air conditioner. It does have a coil in it, so it can precondition the air a little bit, but that's not what it's designed to do. But then we found that combined with the mini splits themselves were not able to do it for us. So what we had to do is put in a supplemental dehumidifier, which essentially, and then we'll get into this later in the video, it essentially couples together, the serve with a dehumidifier. So you take a decentralized dehumidification idea, which let the mini splits do the humidity. You then centralize it with a dehumidifier before you send that conditioned air out to the supplies. So that was the big challenge that we had with the humidity. So the other challenge we had is with it being oversized, we had the classic excessive electrical consumption, and we'll get into that later as well. But so that's sort of how that's the challenge that we had with our initial HVAC design.
Great, thanks, Mike. Well, let's keep heading down
Sure.
and take a look at the ventilation and humidity control system here.
So this is our serve. This is the energy recovery ventilator. This is built by Ben Newell and company out in Champaign, Urbana area. This is what they call a serve. So it's a conditioning energy recovery ventilator, which means it does have an actual evaporator coil in it. This is not a central air conditioner. It is a mechanical ventilator. And when I say ventilator, think of it like a snorkel. Think of it that when you have an airtight home like this, the home needs to be able to breathe, but not in the conventional sense. So in past years, that was the conventional wisdom, is that a home needs to breathe, meaning you had sort of a leaky house, and that was sort of seen as a advantage because that's how you could get moisture out. Get some fresh air. So, let fresh air come into the house naturally. Now in the wintertime, that's a bad thing because you don't want all your heat leaving the house. That's why people, we used to have a wood burning fireplace. That was a lot of our energy was going right up the smokestack, right up the fireplace chimney. But what this does, this basically breathes for the house. It brings in fresh air from the outside, and then it sends it through the supply ducts to all the different rooms. And we also have return ducts in some of the rooms, not all the rooms. Some rooms just have supplies, but we keep the doors open, and that's how the air circulates to those different rooms. It's a smart device, meaning that it actually can detect CO2 levels and VOC levels. And whenever it goes above 1,000 parts per million for CO2, it will go into what's called vent mode. So fresh air comes in, it mixes here, and then it sends it out through this duct into our April air dehumidifier. We put this in after in 2021 because the mini splits and the serve combined were not able to remove enough humidity to keep the moisture below 60% in the house. The April air is basically controlled by the serve, so I can manage the humidity on the serve and say I want it to be 53%. So fresh air comes in, it comes here, it passes through the April air, and it dehumidifies the air down to 53%, and then it sends it through the supplies to the house. So essentially you're taking a decentralized system and you're centralizing the dehumidification part of the system. And this is sort of considered now the way to do it. As a matter of fact, Mitsubishi themselves, because we have a Mitsubishi electric heat pump system, they themselves released a memo back in January of 2019 stating that homes like ours that are using their product really do require supplemental dehumidification. And unfortunately, this was not part of the original HVAC design. It was thought that this device plus our mini splits would be adequate enough to dehumidify the air, and that simply was not the case. So this is good now. The only trade-off here is that we've lost some real estate in the utility room. That's the only really trade-off. And that's really what I think, that's one of the important considerations of anyone looking to do a home like this, is understanding what the trade-offs are going to be. So how do you get the humidity out of here when you take a shower? You're going to get mold. It's an airtight house, right? What are you going to do? You're going to take, in the summertime, you're going to take, 6 showers a week, let's say, or 7 showers a week. How are you going to get the humidity out of this bathroom? What you're going to do is you're going to click this rocker switch. When you click that rocker switch, that sends a signal to the serve to go into vent mode, which it just did. I just heard it around the corner. It's now in vent mode. What that means, it's now taking air out of the space here through that return. So when you click this, it now tells the serve to go into vent mode. That means that every return in the house is now it's now having air being sucked out of that room. Not because there's a fan in the return, it's because the serve is a centralized appliance. So it basically goes into vent mode, so it just basically, its fan turns on and it starts taking air out of every home, of every room in the house. And that's how we get smells out of the bathroom, and that's how we get moisture out of the bathrooms.
Before we move on, Mike, let's and head up to discuss some of the other efficiency features of your home. I just wanted to point out that your project, and as I mentioned at the start, and as you all see in the handout, achieved the EPA Indoor Air Plus certification. And this helped sure the LEED environmental quality EQ prerequisites were met, along with some of the additional credits in low emitting products and other categories. Now, when it comes to ventilation, I want to point out that the ERV you mentioned that you have goes above and beyond what LEED requires for ventilation, and even its enhanced ventilation requirements or opportunities for credits, because it, as you've shown us, it's measuring that air quality and ventilates as poor air quality is detected. So before we got on this, you and I were talking a little bit, just a little more detail that you can share with us on what you're seeing as you're looking at your actual air quality metrics, what's important to you for air quality in your home, and to Amy in your home. Where are you keeping your settings at? Can you just give us a little more information on that, Mike?
Yeah, can you see me?
I can.
You can? Yes? Okay, great, because I can't see myself, but that's all right. So for Amy and I, the most important thing about the indoor air quality, obviously for us, is the humidity, because that's the thing that really panicked us the most. Is, again, homeowners, we were under the impression if you've got too much humidity in an airtight house, you're going to get mold and we did not want to have that. And obviously you want to be able to get smells out. If I burn the bacon, I want to be able to get the smells out, the smoke out of the house, all of that bit, so I don't kick off the fire alarms. But as far as the CO2 rarely goes over 500, if at all. So I think the CO2 is great. Now the VOCs is a different matter, and I've been working with Ty and Ben for a couple of years on trying to figure out the VOC situation. So I think the default factory setting for the VOCs is like 1,000 parts per million, and almost immediately it was above that, the VOCs indoor. At that point, I only had one VOC sensor inside the serve. There are now 2 inside of it now, so I can detect outside VOCs and indoor VOCs. But still, the indoor VOCs are still in excess of 1,000. Now, the way we've gotten around that is just to increase the threshold. So like I've got it set at 1,300 now, so it doesn't vent as much. And in working with Ty and Ben on this, part of it is that we feel that it could be we have just a sensor that's super, super sensitive. So I'm working with them to see how we can resolve that. But the fact is, though, Amy and I don't get sick. We're not sick. I think if there were some sort of toxic VOC situation in the house, we'd be feeling it already. The other thing is that VOCs are like a gigantic bucket, and the sensors we have don't parse out exactly what chemical is being detected. So that's sort of like total VOC package. So, so one thing that we thought about doing is actually getting just a separate VOC or separate sensor, just something that was more dedicated for that purpose, to compare that with the serve and see where we come out. One thing I've said all along since we finished this project was it's like living in a science experiment, chasing down the humidity, chasing down the VOCs, chasing down the electric consumption, all of that. You change one variable at a time, and that's how you do it. But in a house like this, when you panic as a homeowner, sometimes you change multiple things at the same time in hoping to get some sort of reliable data, and that just doesn't work. So, but that's kind of where our view of the indoor air quality sits right now, is trying to figure out the VOC situation and the humidity.
Well, thanks for sharing that, Mike. Let's continue on and looking at some of the other energy efficiency features and your whole home energy usage from a holistic standpoint.
Before we started this project, we had 3 gas appliances, the typical ones, typically you'd have. Gas hot water heater, it was a big tank sitting right about here. We had a gas furnace, it was a horizontal furnace, it was in our crawl space. And we had a gas dryer. Those are the 3 appliances we had before for gas. After this project, we only have 2 gas appliances now. We have a tankless hot water heater, which is still gas, but it's sealed combustion. So these pipes are taking fresh air from the outside. It's actually burning the gas inside of the unit, and all the exhaust goes out through the exhaust flue. Some have asked us why we didn't go electric. One of the reasons was because we already had gas infrastructure here, and we knew that if we had an electric hot water heater, that would probably really increase our electric usage even more. So we said, let's just keep it on gas. And that's another one of the trade-offs, right? Is that a lot of people will say, well, how can you get LEED certification if you have a gas appliance in your house? Well, many LEED homes do still use gas. Some do. As a matter of fact, there's another LEED home in Chicago that uses almost all conventional, and they're LEED certified. So it's not so much about going away from gas completely. It's about compromises and trade-offs. In our case, this is a highly efficient appliance for us. What you're seeing here is this is a wireless dongle, and what that's doing is it's basically behind the panel here. I've got Emporia Energy Sense monitors, which are clipped to certain circuits. So right now I've got different circuits that are actively being monitored for their electric use. The most important one is our mini split system. It's our electric heat pump that is being monitored right now. And then all of our different electrical appliances in the kitchen are being monitored right now. You know, our island oven, our wall cooktop, our island oven, our wall oven, refrigerator, and our freezer. So those are not using as much electricity. What's really using electricity is this. And that's our HVAC branch box. This is where all the mini splits collapse down into this. So it's all the different mini splits we have in the house are represented here. I've got this system plugged into this. That's how we can tell how much energy we're using on those particular circuits. The plan is to put this onto this panel as well. This is all of our lights. This is all the different electrical components we've got in the house, or electrical appliances. When we were looking at how much energy we used before the conversion, it was estimated we were looking at, well, our solar PV designer estimated, or our solar PV designer came up with a figure saying that it looked like we were using about 8,000 kilowatt hours per year for our electrical energy use. That did not take on how much gas we were using, natural gas we were using. Afterwards, what she was doing, she was projecting that after the home was built, we would be using around 10,180 kilowatt hours per year. Now, with that said, it's not an apples to apples comparison because you're changing the actual roof geometry of the house, which means you're creating more space to condition and more space to heat in the house. We actually added a floor upstairs. We went vertical. We went up a level in the house. So that changes the whole volume of the house to begin with. So the square footage of the house increased. So it's really difficult for any contractor, any designer, to predict exactly what your energy use will be afterwards.
All right, before we head on and look at a couple other aspects of the home, is I just want to highlight, all of the items we've discussed here: thermal enclosure, air leakage, insulation, the heat pumps, sealed combustion water heater, energy tracking, and to some extent solar power. All of these get calculated into what's called the HERS index rating, or energy rating index, and which we've listed all in the handout for you to take a look at, along with the LEED energy budget, comparing how a average LEED home should look versus what this home looks like or other homes would look like. And all of this kind of coming together like a soup, right? You throw it in there and you get this you get your negative HERS index rating, which has superseded your targets for the LEED points for energy, which show you get a point for regional priority credits here. And then also a majority or all of the LEED energy points, 36 out of 36, you were able to achieve for your certification. However, with that said, we looked at your actual energy use, and while significantly lower than even today's code built homes, and especially renovated homes with additions on average, you're currently at 50% to net zero in the last year of operation. And one thing we pointed out here was that in May last year, you had a net zero month, and in April, you were just 16 kilowatt hour equivalents away from a net zero month after converting the gas usage. So with all this being said, Mike, can you just share a little bit about your operations, what you're seeing in your usage, how some of these numbers have come up, and give us a little more insight into that?
So basically, I need to clarify something. So what I said in the video was totally unscripted. I just, was talking off the cuff. And looking back at the data, actually, the little guidebook that we got from our solar provider showed that our historic load in 2019, which is pre-remodel, was 10,180 kilowatt hours. Because ComEd in the state of Illinois restricts you to only 110% of your historic load, that limited us to something like 11,500, plus or minus, some change. So that determined the size of our solar PV system that we could have. Now, you can go physically beyond that in the state of Illinois, but if you do that, you are DQ'd from the net metering. So if you want to get advantage of net metering in the state of Illinois, you have to conform to what ComEd wants as far as your sizing. So we have the option right now, it's another trade-off. We have the option of putting additional solar panels on our garage terrace. But, and we knew that actually back in 2020, when we were first doing it, that we had that option. But Amy and I decided the most important thing to us is that we were able to grow food on that garage terrace. And that was specifically how we got Arlington Heights to approve that garage terrace being added to our project plan. Is they wanted to know what use it was going to be. They said people put in, garage terraces in Arlington Heights and they never get used for anything. And like we said, our use, we're going to be using that to grow food. So that was the reason why we did not put solar up there. Part of that was because we thought that the thermal envelope and everything else that was being done would be what we had as far as solar coverage would be adequate. Our solar's produced wonderfully. Now, we've had some unlucky incidents. You want to have a good data all the time, every year. 2020 obviously was a construction year. So, we didn't move back until January. So there's no one in the house while it's being constructed. So that doesn't count. Even though the PV system went live August of 2020, it was building a lot of solar energy, in the net metering account. But, that was great. We went into the winter with a surplus, which is great. 2021 was the year when we realized that we had the oversized issue. I had to buy a Home Depot dehumidifier and keep it on 24/7 from Memorial Day till the second week of August when we had that April air installed. So now the April air is not free, is it? Because that takes electricity as well. So that was not part of the original plan. So that wasn't part of the original. Are you going to be having this appliance was not part of the design. So that's an additional electrical component we didn't count on. 2022, unfortunately, in mid-May, our inverter died. So that's when we first felt the very first sting of COVID's supply chain issue. So the inverter, it took us a full month, a month and a half actually, to get that inverter installed. So it took literally till the end of June. So we lost a full month and a half of solar production. So that year, there was no chance for us to be anywhere near net zero. Last year was our best year, and that's what Brett was showing there. Now, to be perfectly honest, the reason why that one interval was so good is because Amy and I were out of town for almost a month celebrating our 26th anniversary. So we were not here in the house at that time. So you can see that's why that particular interval looks really good. And I mean, that's kind of silly, right? To say the only way that you can be net zero is don't live in a house. We don't want people to think that. So, again, there's another person that I trust that's basically like, homeowners often, a lot of the energy consumption has to do just with behaviors. And we haven't fully identified which behaviors of ours are causing perhaps the excessive electricity consumption. I mean, again, I like it cooler in the summer. Amy, like, she's okay with having the heat. I mean, yeah, I play electric guitar, but that's not going to jack it up. So we're still trying to figure out what was really causing this. And I see some of the comments, some of the people are showing, yes, you are oversized, and that's probably contributing to the overage of electricity usage. And I've had that. I know that as well in my mind as well, that's part of it. And how are we going to resolve that? Well, we've already spent, $6 million on the house. So how many more $1 million do you want to spend? I'm in negotiations right now with another HVAC contractor on how could we possibly swap out this 4-ton unit, get 2 smaller units, perhaps get smaller wall units, and right size it. Fortunately for us, the line sets we have currently do not need to be replaced. So there's no drywall that needs to be hacked open. Frankly, I don't think we can take that anymore. We already went through that for a year. So there are ways to get around it. I mean, Brett has suggested getting, which I'm going to investigate this, is getting a heat pump water heater. That's something we can do. So there's a lot of things we can continue to explore. I think this is part of the journey, part of the experience for someone that is a pioneer on this. Again, we're the first home in Arlington Heights, at least, and one of 2 that I'm aware of that have actually remodeled to LEED Platinum. A lot of homes, there's a lot of brand new LEED homes. There's an architect that that we met with. We did our due diligence. The architect that we didn't select, he's only done new LEED, and this isn't a new home. So the reason why this is so rare is because it's expensive and no one really does this. How do you take a 64 split and make it energy efficient without completely tearing it down and building it up again? You might as well buy a new house. So someone has to be the pioneer and sort of forge the path so other people can learn from our mistakes. And that's kind of what we've experienced. So that's a long-winded answer, but that's kind of what it is.
Yeah. Well, thanks, Mike. And there is a lot more than energy efficiency, decarbonization, and quite frankly, even health and ventilation, which still gets missed these days, unfortunately, that goes into green building LEED certification that we don't often talk about. And so I'm really excited to continue on this tour and get into some of the other areas that often get missed when we talk about home renovations or even new construction. So let's continue on.
So one of the components of getting LEED certified is water efficiency. And you can take 2 paths. You can take the credit path, or you can take the performance path. And quickly we realized that our scope of work here was going to involve a lot of landscaping outside. That was going to involve a lot of water efficiency externals of the house. So we elected to completely forego the indoor route, or the credit route, or the prescriptive route, as it's called. Although we did put in water sense features with optimal flow rates for both of our kitchen sinks. We also put in good flow rate toilets. We put 2 new toilets in. We'll show you those in a second. And shower heads. So the really cool addition that we did in our master, besides the finished sauna, is we put in a bidet toilet. But this is a great way of not using as much paper. As a matter of fact, it takes much more water to manufacture a single roll of toilet paper than it does to flush, when you're using a bidet. So if you take it over an equal period of time, you can go out and look at the research yourself. Don't take my word for it, but it takes a lot more water just to make a roll of toilet paper. So now all the rest of the fixtures in here, these are all water sense fixtures. The shower heads, these have a certain flow rate. So you're maintaining the water efficiency here. And we'd already gone down the prescriptive path for a lot of our water fixtures before we realized we're going to get into this big landscaping deal that we're going to be not needing to do all of this indoors, but we did it anyway because we wanted to have water efficient appliances inside. So part of the materials, so another one of the component of LEED certification is the materials that you use. So you want to have materials that don't off gas. You want to have materials that don't impart a lot of nasty chemicals into the house. And so the biggest contributor to that is going to be your paint. So we had to go with low to no VOC paint in our house. We're talking trade-offs again here, right? Because that's what a home like this, you're trading one thing for the other. What you get in the benefit of having low VOC paint is it's not very washable. And you get a smudge on this kind of paint and you essentially have to always have a spare can of paint with you. So you can't really use cleaning supplies to clean that kind of paint off. You just have to kind of repaint and touch it up again. Let's go downstairs to the kitchen. And we chose some of the appliances because they're energy efficient to begin with, but also because they're functional and function the way that we wanted. And so this is our favorite appliance right here. This is great. It looks just like a regular toaster oven, but it is an air fryer as well. We use this for almost everything. And we have a conventional wall oven that we have down here, which is just fine. So, you know, we have essentially two convection ovens and a third convection oven here. This is our microwave. This is, you know, it's called a speed oven, which means it's a microwave functionally, but it can also serve as a convection oven. To this day, we have not turned on the convection on this. We've not used it as a convection. We use this solely as a microwave. But essentially, we've got 3 convection ovens, or I like to say 2.5 convection ovens. This is all refrigerator. This is an Energy Star rated refrigerator. We wanted to have a home that is functional for us as well. So the community aspect was important, the functional aspect was important, and of course the sustainability aspect was important as well. The sustainability aspect is obviously where LEED comes in the strongest. So the house expresses sustainability because of all of its energy efficient features and benefits. But really where it expresses its most strong sustainability is outside in the landscaping, which we'll show you in a sec. So mowing the yard, as it used to be called, back in the year 2000 when we first moved in here, was terrible because you had to constantly reach down and pick up pine branches to be able to mow the grass. I thought, let's put a garden in. So in 2012, we put our first vegetable garden in, which was right back there to the right of the shed. And it went from maybe about where the 2 raised beds are now to where the shed is. And that was the first vegetable garden that we ever had. Over the years, we just wanted to have more fruit and vegetables in the yard. And so when we looked at doing the landscape, we said, well, it has to do several things. It's got to be able to produce food. It's got to be able to hold and capture water. It's got to be able to obviously be a place to entertain. And it's got to be a landscape that is self-regulating. And that was kind of the plan. So that's what the self-regulating part is, where the rain gardens came from. So the rain gardens actually express 2 things. They capture water and they also self-regulate. So this is planted with the front and the back. Rain gardens are planted with over 2,300 native Illinois plants spanning 34 species of sedges and forbs. And so a lot of this is all native to Illinois here. Now the vegetables are not, obviously, but all of the other plants you see here are. The geometry of the beds are basically informed by what's called the percolation test. So what my wife and I did in September of 2020 is we ran around and dug 6 Home Depot bucket-sized holes in the yard. And we had to fill those holes with water until the water stopped going down. And then we put about 3 inches of pea gravel in the bottom of each hole and took a tomato can and cut the top and the bottom off and set that into the gravel. Then you pour water into the tomato can, and then you sit there and you measure how long it takes the water to go down every 15 minutes. So every 15 minutes you'd put a ruler to see how far the water had gone down in the tomato can. And then you would just keep filling the water back up in the tomato can to get a sense of how, what your percolation rate is, your infiltration rate. And what we found is that the holes we dug back here, the infiltration rate was like 3.5 to 4 inches per hour, which is fantastic. Now, no engineer will believe that soil in this area will infiltrate at that rate, but this did. But this is essentially expressing this idea of a self-regulating landscape with native plants that don't need a lot of water because their taproot systems penetrate deeply, and that opens up better soil conditions for microorganisms. So you're really creating a robust soil food web there because you're allowing more oxygen and more water to penetrate down to the root layer. And that just attracts more microflora. So the water harvesting system, this is a 1,200 gallon system composed of 5 ICB tanks, all connected in the front with a single manifold in the front. So the idea is you have tanks 1 and 5, and all the water that comes off the roof, all the roof runoff is directed to 2 first flush filters. So you can see behind me here, in here, that is a first flush filter, this white array here. When that fills up, that basically is filled up with all of the, let's say, the bird poop and other pathogen-laden stuff that gets in the water whenever an animal or a bird poops on the roof or in the gutter. All of that runoff is captured here in the first flush. And then I have a timer that allows me to flush that out at certain intervals. So the idea, though, is that you flush it out a couple times until you get that's what they call it, first flush. You get all of that bad water out of your gutters until it's all clean. The next big rainfall, it'll fill up the first flush system. That allows the water to go in to the black filters, which we'll show you in the next shot. So tanks 1 and 5 have filters on top. So that basically allows the water to go into tanks 1 and 5. And then the water fills up tanks 1 and 5, but at the same time, it's filling up the manifold in the front. That's what allows tanks 2, 3, and 4 to fill up simultaneously. So the entire system fills up at the same rate because of the manifold in the front. The way to tell when the tanks are full is here at my feet. This is the overflow. When the water reaches this level here, when the water's at the top of the tank, that means that it's at the top. That means it's at a level where it'll start going through this pipe. And that means it'll start coming out here. So that's how I can tell when the tanks are full. When I start seeing water coming out of this end here and the end over there, I know the tanks are full. So this is now pressurized. So the pump pressurizes the whole system. This is now pressurized. So this is actually rainwater coming out of the tanks. Yeah, so the manifold connects to this pump, and the pump then allows us to pump water out here from the tanks directly. Also, we ran line sets out, so we have plumbing lines going underneath the landscaping that branch off in 2 directions. So in wintertime, in about a month from now, when it's time to purge the tanks, this valve here and the one over there, I'll simply open these valves, and this is what happens. And that's how I get the water out. And the water comes down these 2 spillways, and it fills the rain garden up. And of course, because we got about 4 inches infiltration rate per hour, all those tanks, it's gone like in a couple hours. It's just no longer there. It's all gone into the ground. So the rain gardens serve, multiple purposes. They allow us to obviously support a native landscape, They allow us to hold and trap water on the property that doesn't go to your foundation, and it allows us a place to purge the tanks when the rainwater system is no longer being used. So it provides three purposes. Yeah, so this is these are all Panasonic panels. So we had to change the roof geometry of the house to get as much southern exposure as possible. And that was possible by raising the front for our new addition in the front of the house. And this is the original roof on the back. So what's close to us here? Well, we're within a mile of the train station. So we can walk to the train station. We actually have a grocery store about a half mile away. There's a park just over right behind us. There's plenty of schools here within walking distance. We prefer to walk a lot around the neighborhood. It's really nice. But so we're about a mile away from the public library as well. So that's all the different amenities that we're close to.
All right, well, we are about to wrap this session up before we get into our Q&A. And just again, real quick, to summarize and to highlight and kind of go in a little bit of a deeper dive on what we just talked about. As I mentioned, a lot of times we're getting, even when it comes to residential green building certification, we're getting hyper focused on decarbonization, air sealing, insulation, weatherization, solar, especially with the Inflation Reduction Act now, which Mike and Amy started their project long before that wasn't influencing them. But even still, we're getting really fixated on these strategies, which is great. And there's resources coming for them to help everyone do things like this. But it's just really refreshing to me to again see holistic sustainability happen. That's what LEED encourages, looking beyond just the energy conservation and going out into that site and going out into the community at large and the connectivity of the community, which encourages walkability and other aspects. And so I just really want to say how much I appreciate that phenomenal work and continue to highlight that and that inspiration. And where it leads to several LEED points is LEED water efficiency, total water performance, and LEED sustainable site rainwater management. And as water bills skyrocket and city infrastructure is strained, it's very important for everyone to do this with their homes and their buildings. So let's take a look how this plays out on LEED. Overall, you can see they got 13 of the 15 points available in water efficiency. And Mike used the performance pathway and achieved a 74% reduction in total water use compared to the standard home. And if you look at the handout, you'll see that there's at least an 86% reduction below the EPA's water budget baseline for the traditional home with the same size and landscape, or which would have conventional landscape anyway. And so you can see on the slide here, reduction in LEED allows them to include all the rainwater catchment as well, which stands outside of the water budget. It doesn't include rainwater catchment. Now, I did a little exercise here before this session. I removed all of the outdoor water use from Mike's checklist. And you can see at the bottom, it would have knocked Mike and Amy's project down from 74% savings in total water use to 34% savings in total water use, a total loss of 8 LEED points. And this is stunning to me because typically I see most of the water use in projects focused on the interior, not the exterior. And so it's been such a huge impact for them for what they did. And it goes beyond just saving water. And that's what I love about LEED and sustainability. There's always 2-for-1s and there are always win-wins that I want to highlight here. So you can see if we jump over to the sustainable sites credit rainwater management section, you can get points here also for all the work that they did, besides saving water, they got exemplary performance in keeping the stormwater out of the city infrastructure, above 80% reduction, as well as an impermeable reduction of impermeable spaces to filter that water, as Mike described. And and then also just following some basic good landscaping practices, which LEED ultimately lays out. So with that, Mike, if it's all right with you, we're going to stick around for those who can and get into some questions and Q&A and further clarification. So Mike, Amy, are you okay with sticking around a little bit and joining us for that?
Absolutely.
Sure thing.
Yeah,
Yeah,
I was
great.
looking at the Q&A, and I don't know how you want to do it. I mean, if there's things that are like electric related and materials related, we could maybe answer all of the, put them in themes and just answer them that way versus trying to get all 11 answered in order.
Yeah,
however you want to do it.
I do like that idea, and I kind of want to go back to your thermal envelope and some of the questions that came up with that. One of the questions was just considerations of, the materials that you use. This individual mentioned a specific material, but let me just ask it in a broad way. Now, and again, back then this wasn't trendy, but now it is it reducing what we call our upfront carbon. That's the carbon locked into materials. And so we know some materials like rigid foam and other foams have higher carbon locked into them. Was that even a conversation on your thought? Was there other material choices presented to you outside of the rigid foam or other aspects when you were looking?
Yeah, I got questions like this from other people. They asked about rock wool, and they said, are you using, any kind of natural insulation material? And I said, talk to my architect. He's the guy that knows all the answers. And, I think with projects like this, and this is part of my development as a human being, is I've been trying to do less of this after the project. Like, I should have known better. I researched the dickens out of this. I bought 3 or 4 books. We interviewed all sorts of people. I researched, to the nth degree online, and still there were gaps, so I didn't have the materials expertise. I certainly didn't have the HVAC expertise. If I could have a time machine and go back, I could absolutely guarantee we would have everything. One of the things I remember hearing a lot whenever we were talking about, why are we not doing an electric, heat? Why are we not doing an electric water heater? And certainly one of the answers was, well, you've already got gas. And I kind of thought, well, that doesn't seem like, that's not really an answer. It's more of just well, you already had gas here, so just do gas. And so there wasn't really an investigation. In my view, it wasn't an investigation on that side. Now, the other thing to clarify, we did something other people thought was strange. We hired our architect as our construction manager. And one of the reasons why we did that, and I know Amy's going to get into this a little later about the cost, is that, and it wasn't $6 million. I'm just joking, obviously. It was $60 million. So one of the reasons is, I forgot what I was saying. Anyway, so
talking about hiring.
Yeah. So we hired our architect as our construction manager. And that was because we had been told that usually a GC is going to cost you 15 to 20% of the total project cost. And we got a significant discount from this person to become the construction manager. The big lesson learned for us is that an architect is not necessarily a good construction manager, because the skill set's different. A general contractor knows how to enforce and when a sub is not performing, and so I think and people are human beings as well. So you were going to add something.
Well, and I think, certainly there was a cost discount to using the same person, but we also went with an individual who had experience construction managing. It was certainly not just a cost, and it was also the notion of doing something that's so pioneering. There's the notion of continuity. I've managed enough projects in the corporate setting, and when you don't have a task done just by one person, but you're splitting anything up, it's a challenge. So, you know, and it was a bit like, well, do you hire a builder, construction manager who doesn't necessarily have experience doing LEED or sustainable home renovations? Because again, we've all agreed, I think already on the seminar, it's pretty new, you know, to do what we were doing. So I think we also saw a benefit of having continuity in having the same person, same messaging to people, you know. But what you risk, and I'm a consultant and I understand that, is what you risk is not having two individuals is you don't necessarily have the creative tension that's very healthy sometimes between client and consultant, or, you know, in this case, architect and builder, because sometimes there could be healthy tension that comes up with a better answer than just one. So I don't think any project management experience is ever perfect. And I don't think there's an easy equation for doing this kind of home with the existing experts who are out there, because still there's not so many. You know, so we, you know, I'm not sure how we would redo it, but we might want to have somebody else then managing it. But we'd want to make sure they have an understanding. And I don't think there's always that.
Yeah, there's another important consideration here. We're all human beings, right? So some human beings are okay with conflict. Some human beings avoid conflict at all costs. Now, if you've ever done a project with subcontractors and contractors, there's the potential for conflict. And if you're not up to actually holding someone accountable to their performance, then, you know, you're going to, so for example, we had walls that weren't straight. You know, I walked into a room and I got vertigo because it was like I was in an Escher diagram or something. It was in some non-Euclidean geometry going on. And I'm like, what's going on? So I could see that the wall wasn't straight. It was the trim on the door, it was coming down to a point. I'm like, how is that possible? It should all be parallel. And it wasn't, because the walls weren't straight. So, you know, some of that was just, you know, any construction project is going to have flubs like that. And so again, we've in the last 4 years had to become very forgiving of things versus a lot of this. There was a lot of that going on in 2020, you know, and a lot of this going on in 2020.
And at the end of the day, you're the homeowner. So ultimately the accountability sits with you. So that's why we felt it was pretty important to get close to it. So no matter what, if we were to rewind time, we'd maybe even get closer to it than we were. And yet I know people are like, you guys are consumed with this, but it's what everyone says about any home renovation, whether it's green or not, it's a challenging, it's just challenging to go through, you know, and there are always missteps, you know, and learnings. So
yeah. So then, as far as the two cost questions, so no, it did not cost $6 million. So you could mark that one as answered. But Amy can actually talk about the cost now, and that'll cover two questions.
Yeah, I mean, cost-wise, finances are often in my mind in terms of our relationship over the years. So I'm kind of the one who's always like, okay, what about the cost? What's the ROI? I'm just going to say up front, I might have said this earlier when I introduced us, but, you know, this wasn't about financial return. You know, notice financial was not one of the three pillars of our philosophy. Doesn't mean we didn't think about it, because we had to have money, obviously, to fund it. And I had to come to terms with this moving forward, because in my own life, I'm often investing based on return financially. Other options would have been way more fiscally savvy, like simply moving to another home to get a bit more space, right? Or, yeah, maybe buying some land and building it from the ground up. Who knows? But we did this obviously to stay in the neighborhood, as we mentioned, and create really an example home. And I see some of the comments like, thanks for your wonderful project, you're pioneering. And so we recognize that with that, you know, may come cost, but we wanted an example home that really expresses who we are and that really what we believe in terms of sustainable living, what we would hope for the future on the planet. And so, you know, we chose not to have kids. That was a very intentional decision in our marriage. And we kind of realized this project was like our kids. You know, so a way we could contribute to and impact the community. So, you know, consider the cost today of raising 2 or 3 children and sending them to university, right? When we really like crunch the numbers and look at the actual project costs of like the house structure and renovating that and the materials, you could say the cost is maybe somewhere around 250 square feet. Maybe $300 per square feet, is somewhere in that range. But again, as Brett just said, we didn't benefit from the Inflation Reduction Act, although we got obviously some credit from solar and from the deconstruction process, the materials contributed or donated. But when I step back and consider the investment, I think the key aspect is we could stay on this street. And I think for myself, it was about realizing there's just naturally a significant return on your investment from being in a tight-knit community where when we go on vacation, we know our house is safe. When we have a package that's left on the front, we forget about it, someone literally calls us, just like we do for others. If you consider ever a health emergency, and we all will have them as we get older, or a home emergency, wow, having a tight-knit neighborhood, to me, that's priceless and that's worth the investment. So that was, a key consideration for us and how we thought about it financially. We looked more broadly, like Brett, you're saying, we looked more broadly at sustainability as well, very broadly.
Yeah, I think the other thing to consider there is, we don't have a security camera in the front of the house. The neighbors are the security camera, if you know what I mean. So that's the benefit of being in a place for as long as we've been here. We've been here for what, 20?
Oh, we bought in 2000.
2000. We've been here for 24 years. So, so that should handle the two cost issues. And and Amy's right. We didn't do this to get return on the investment. And I understand that's sometimes that is the driving factor for a lot of people, not just on the individual homeowner, but for larger projects. It's, you have to do it at the right cost, especially if you're using like municipal funds. So totally get that. But for us, this was a passion project.
Well, it was I think it's really about reframing what do we mean by ROI, right? So I think this project is a way to start to say, how do we reframe what truly constitutes success?
I think the payoff here is, when people go by, people are always looking in, because we have a pit in our front yard. And that's the other change. I keep using the word yard. We don't have a yard anymore. We have a little strip of grass in between the sidewalk and the street. That's the only thing that has to be mowed now. And I have a little electric mower that does it in literally 5 minutes. But when you get questions of when are you putting the grass in, because they see this, this dirt landscape and they don't know what's going to go there, that creates, the questions, that creates sort of this opportunity for dialogue. And so that was a part of the project that actually I really enjoyed, is the opportunity to educate people. The other thing I was going to mention about the water savings is another benefit. And it's hard sometimes for people that aren't experiencing a flood in their basement to understand is what we're doing here. We're capturing every drop of water that falls on the landscape and directing from all the impervious surfaces. So whatever water falls on the driveway, whatever falls on the garage terrace, whatever falls on the walkways, and our patio, all of that water is graded. All of those impervious surfaces are graded to channel water into the rain garden. So what the effect that has on the neighborhood is that water does not go into the shared sewer system. And if you are on a shared sewer system and you get a significant rainfall, and you might have your sewerage back up into your basement. So that's one thing to consider about, taking the more holistic approach and not just focusing solely upon the energy, but because, you might save a lot of money with your energy costs, but if you have to spend $17,000 to, have your floor removed, to have your home dug up, that wipes out those savings really quickly. So I think having that holistic approach is smart. So I'll get into some of the detailed things here. So no, we didn't have any grants to fund the project. I wish we did. If we could do it again, we would try to find ways to do it.
If we knew.
We'd be begging on the street, give us money. Good question. So Deborah Coleman asked wondering what the HVAC designer had to say with later need to dehumidify. I blame COVID. So because it really distracted a lot of people, I think that we have not yet gotten a full answer on this. And that's because her parents had health challenges in 2021. We started a blog, we started a website. We had to just stop that to take care of her parents. We became caregivers like in an instant. And we have not been able to chase down all of these loose ends for the project as far as who's accountable for what. What I know from our perspective is a way to resolve it is to right size the system. That should put us on a trajectory to be more energy efficient and get to net zero. We have options, as I said earlier, putting in the heat pump based water tank. That's one way to do it. And before adding the solar panels to the roof, did you re-roof the roof? Yes. So we had a new roof put on, and it was what was called? It was conventional shingles, but it was a percentage of the materials were recycled.
Yes.
I remember that.
Yes.
But I can't remember the specific. I can't remember that.
Yeah.
I believe there were architectural shingles, but I'm not entirely sure.
Yep. And Mike, going back, I wanted to get back on the HVAC real quick to another part of Deborah's comment. I know it's a big comment. And I was wondering the same thing too, as I was reading it, is, did you do any kind of trade-off analysis between considering air source and, what people call geothermal or ground source technology? Was that considered at the beginning?
Yeah, I did sit with someone at one of the Echo Achiever hosted. Echo Achiever was our third party rater here for this project, and I went to one of their hosted events and actually sat at a table with a geothermal provider, and which I later learned is that's the fancy misnomer for ground source heat pump. And we looked at that, but one of the things, this is where it got confusing, because to do that you would have to, my understanding is you'd have to, impact the ground, do things in the ground. And we had other plans for the ground. We wanted the soil to be used for growing food and for storing the water in the rain gardens. We were looking at putting in an actual cistern under the ground to do water storage. So that at the time, the ground based wasn't what we wanted to do. And we were told that, this is what everyone's doing. It's the electric heat pump. And so that we thought, okay, well, at some point you have to trust the experts that they know what they're doing. And we did. And again, people are fallible. People aren't perfect. So I don't think people tried to sell us a snake oil or anything like that. I think it's just people are trying to do the right thing. And sometimes it's not right, so.
And sometimes the project is challenging.
Sometimes the project is challenging. So, there's all sorts of things. Now I feel like I would love to be a person that helps other homeowners out. I think it would be great if, like the Wizard of Oz, when he is behind that curtain and he's pulling the dials and pushing the buttons, he's changing all these variables. If there was some sort of a way that homeowners could see, if I change this variable, the cost does this. If I change this variable, my sustainability goes down. If I change this, it goes way up and the cost goes down. Well, let's do that. Let's use that technique. So there needs to be some sort of a control panel where you can move the sliders so you can see exactly what your trade-offs are. And I think that's where you hire a human being to do that. Unless you have a human being that's done it before. And our guy hadn't done it before. He had done new LEED construction and he had done conventional remodel. But he, nor anyone else we interviewed, had ever done LEED remodel. And that's the big difference, I think, for our experience. So
Totally new.
Yeah.
So who knows, right?
Yeah, no. And I think, as you mentioned, you want to help educate, and so you were doing it right now. So certainly appreciate your time on this and having that conversation. A couple other, sticking with the sort of, again, that sort of trade-off, those decisions in the beginning around the HVAC system. It looked like, you went from a central ducted furnace to the, multi-split head approach. Was there a consideration of staying with a ducted air source heat pump system as part of the conversation?
For about 5 seconds, when we pushed back a little bit, asking about, is this the right way to go? The response we got was, well, you can still do a conventional furnace. And I was like, no, we don't want that. We don't want that. Not terrible. I didn't want to do that at all. So I didn't give that much consideration. And I see the question, what was the deciding factor for multi-zone unit over a few single zone units or a ducted system? So the ducted was right out.
Well, and when I say ducted, I want to be clear. I'm not talking about gas ducted. I'm talking about air source ducted. Did that come up into consideration? Because I think you were knocking the out because of the gas, right?
No. Well, it was the gas. Exactly. Yeah. To me, ducted equaled gas furnace to me.
So there's actually ducted air source systems, and was that presented to you? Was that an easy, like, nope, it's not going to be ducted, like that just can't be the way?
No, I did not investigate that.
Okay.
I did not. Now there was one thing at the original HVAC design that we had called for a fewer number of mini splits and then an air handler that would basically do the condition for an entire floor. And that was the original HVAC design that the HVAC designer that was contracted provided to the architect. For reasons we still have not learned, the architect decided to eschew that design and go with the design that we have now, which is 5 mini splits and the big 48,000 ton unit in the back. So that's how we got where we got. But we did have an air handler that was supposed to be doing the job for for our second floor. Whereas now we have 2 mini splits, one of which was just barely used. So it's sort of like it's like a wall ornament. It doesn't really get used. But so again, learnings.
It's all about
And so the other question that came up is, again, looking at alternatives to the wall envelope from a humidity, right? A humidity concern. And so there's some folks say we should use vapor open materials. So the rigid foam you had is closed. It sort of prevents that. Was there any conversation in the design stage about a permeable open approach?
Nothing that I ever heard. And my question is, how much of these technologies and these methods came about like after our project versus how much of this stuff was known and actually used on a consistent basis prior to our project? And that's some of the gaps that I would have hoped that the person we hired would have been able to fully take a look at that. But, we were not really presented with a lot of options from which to choose. It was sort of like, this is the way this works. This is the way people are doing it. This is what I suggest. And I didn't have enough knowledge to push back and say, well, what about this material? What about this method? What about this particular model? And, so so it didn't possess that knowledge back in 2019 when we were finding your names to the paperwork.
Yeah. No, that makes sense. And sometimes, asking that question is, did it exist or not? Or is also the question is, did it exist here at the time or not? I mean, because a lot of things exist, in California or Europe, but they just haven't made their way here, right?
And that's the thing. Not knowing what I know now, going back and looking at it, I know that sometimes when we asked about, well, what I learned is, where are you going to get these materials from? You're going to ship it all the way from California. And granted, we were not impacted by the supply chain crisis in 2020 because all the materials had already been pre-purchased. And thankfully, we were already 3 months into the project. We broke ground and deconstruction started in January. COVID, of course, we know didn't hit till like the second week of March when people officially got shut down in different states. So we had about 3.5 months to sort of get those main materials, purchased, ordered, and actually on site before any of that happened. So a lot of those decisions were made, in 2019, long before we started. And of course, I did have conversations with people after I'd already signed, like, this is the material we're going to go, this is the route we're going to go. And hindsight's 2020. So that thing, and I think a lot of people have experienced this kind of thing. I mean, today it's the heat pump water heater. What's it going to be tomorrow? What if what if fishing comes out tomorrow? So then it all makes it moot, right? So so the last one here is about the PV panels. Would ComEd be concerned about any PV panels over the nominal 110% if they were not connected into the net metering, perhaps dedicated to EV charging or other off-road? I can't answer that on ComEd's behalf. I just know that if you go beyond that 110, that incentivizes you to have battery backup. Because I know that Brett in the state of Michigan, he told us yesterday, they don't even have the option to do net metering. So basically, you have to have a backup battery to sort of store all of your energy. Whereas here in Illinois, you can take advantage of the net metering. Now, you could do that here. You could do a backup battery here and I suppose, take advantage of that. That was another trade-off for us. The only real estate we had for a backup battery would have been in our garage, outside the garage, in the well that connects the house to the garage, or in the utility room. And we simply did not have the floor space for that. And plus, that was the one thing we got sticker shock on, was the amount of money just for a battery like that. That just, I'm like, oh my God, we've already spent, I said $6 million on this. we were done. We didn't want to spend anymore. So, and that's something we might consider now because, you know, with power outages, I know that's why you have this, Brett, and some people also have the battery backup, is when you have a power outage in a house like this, it can really stink, you know. The big double whammy for me that I've always been frightened of is in the wintertime. Thank God we don't live in Virginia where ice storms snap trees in half, which take electric poles down. In Illinois, to knock on my artificial wood table here, we have never had a power outage in the winter. So if we ever had the polar vortex, which is the negative, you know, whatever, the negative 15, 18, whatever it is, when your mini splits really stop working, when that air source heat pump no longer really generates enough heat. If you have that happening plus a power outage at the same time, what do all electric homes do? And you probably should have a backup battery if that's going to happen. Thankfully, that has not happened with us. What we do have is that gas fireplace. That is our backup emergency heat, sealed combustion fireplace. We've only used it once. That was like in the winter when we first moved home. It has not even been on for the last 3 years because we just haven't needed it because the electric-based heat has been perfectly adequate for us. So,
Right.
but you know, if that were to happen, there was a blower motor in the back of that Napoleon fireplace, and basically that would blow air out. Now, if the power goes out, how are you going to power the blower motor? Well, our architect told us that the AAA batteries inside of the piezo igniter would power the blower motor. No, so things like that. You know, so yeah, there's again, it's like a science experiment. You're constantly chasing variables, and that's what we do all the time here, or I do. She tries to calm me down. I do all the chasing and panic. So.
Been a learning process, but a good one in many ways. And I just have to make this final comment because it all comes back to community and why we stayed. So just a few minutes ago, as we were chatting about various technical details, I got a text from one of my neighbors to say there was a duck on your roof this morning at 6:45. Okay, we live in a neighborhood where our neighbor notices that. We're such good friends, and she had to tell me there's a duck on my roof at 6:45. How awesome is that? Hello. Because somebody did say, yes, staying was, we're glad you made the choice to stay. It is worth the investment, right? So thanks to those of you who get that value from the neighborhood.
I mean, my belief is that, you know, we go on vacation, we often look at like the real estate listings, like outside, what town we're walking in. And one of the things that drove the decision to do this in the house is I had this kind of weird belief that in 20 years, 25 years, when the next generation of youngins that are currently growing up in Chicago right now, this is what happens in Chicago. People get married and they have kids and they get out of Chicago and they move out to the suburbs. Marriage, mortgage, and munchkins, those 3 M's, you know. And that's when people really start, you know, engaging in things like this. And I have to believe that in 20 years or so, maybe hopefully sooner, that real estate, when you're doing real estate, that, you know, you'll have a checklist. Like people will have a punch list to say, oh, I'm looking for a home that provides this much of electricity. It captures this much water. It's got this sort of performance level for its indoor air quality. You know, that those are the standards. Now, over in Europe, for example, any real estate listing in France, for example, it gives you a rating. You see it. They have it posted. It's
where we're going.
By law. It tells you this is how much energy this home saves. This is the rating that it received.
It's like a letter grade almost.
It gives it like a letter
grade.
It's like an A to
an
F. Yes.
Yeah.
And so I think if homeowners had that to do their home shopping, that would make what we're trying to do here, that would really incentivize people to go this route. To increase the resale value of the home. Right now, it's a marketing sales job to get it done. But once you legislate that, that I think makes it really important. So
yeah. Well, stay tuned for that, everyone. There are some things brewing with that, with some of the legislation that's passed in the state funding, but a great thing to highlight. So, Mike and Amy, where I guess before we wrap up, I know you're going to start. You mentioned you've got the ability to now start tracking your plug loads, get a sense of where your energy using. Maybe you'll be sharing that on a blog or what?
Sure,
where can
absolutely.
people learn more?
Yeah, so if you go to our website, happyboolo.com, you're going to see the whole story of how we started this, the whole vision, the whole philosophy, everything that drove, you know, why we did this. If you follow the blog, you'll see the chronology of the construction. That stops in around September of 2020. whenever we were having the staircase put in, because that's when we stopped. Not at that time, but we were writing the blog after we moved in, obviously. So we stopped contributing to the blog around March of 2021. In the blog itself, it stops around 2020. So we have not put a blog post in about all the stuff I've talked about with the HVAC. We haven't talked about all the landscape. We haven't talked about the air quality. We haven't talked about the materials yet. So there's a lot more that we were going to be sharing, absolutely. And one of the things will be, once I get those Emporia monitors on every single circuit in the house, and I get my account back with Emporia, I'll be able to see exactly how much electricity that our HVAC system is using, which should put us over the top to say, yes, you are absolutely oversized. This is not optimal. You've got data to back that up. Right now, I have feelings that it's oversized. What I don't have is proof that it's oversized.
Sure.
So, and I think that's what I just need to feel comfortable to spend another dime on this, is I need proof that it is oversized. And then I need proof, if I'm going to spend that money, that is going to fix the problem.
Yeah.
So that's the thing. So
yeah. But our hope is definitely to get back to sharing and chronicling. That's been
Yes.
our hope. It's taken a while. We've had other
I blame COVID.
We've had my parents' challenges in his family.
Yeah.
So we hope to do more, because that was always part of it, right? Part of the community aspect of our philosophy too was share along the way. We've gotten neighbors interested. We have a neighbor, they didn't go green with their home renovation, but they actually chose to renovate. They need more they need more space. They have more kids. And they said, we're staying, and we're going to take just some of the things, maybe not the green aspects, but some of the things you guys learned. And so they did that. They stayed on that street. They have a beautiful home renovation.
And then when we started the landscape, they moved.
No, they didn't move. They're still there. He's kidding. Just like the $6 million.
Yeah.
Anyway,
so yeah.
Yeah. All right. Well, Amy Myers, Mike Baker, I appreciate everything you've done and going through all of this and continuing to share everything with everybody and our audience, and taking your time to do this. And I'll be looking forward to check out your blog and learn more, and maybe share it out as you update, continued information. So again, thank you for your time. Thank you all for joining us as well. And we'll be on again next Wednesday at noon. So we'll catch you at the next session. So take care. Be well, everybody. Bye.
Thank you so much.
Bye-bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.